Well, welcome to our next level 3 differentiation video. And we're closing in on the end of these videos for level 3 differentiation. Funny to note that this video you're going to talk about now is probably one of the ones we should have started with at the beginning. But nevertheless, let's get into what limits are all about. In mathematics, a limit is the value a function approaches as the input value, which we call x, approaches some particular value. Right, here's an example. Y is equal to x squared, which is just a parabola function. We're going to plot some points and show you what's going on. So let's pick a value of 1, which is our input value. And let's work out the y value by sticking that into the function 1 squared, which gives us 1. So when x is 1, y is 1. As we increase x to 1.5 and get 1.5 squared is 2.25, and we increase x again to 1.8, we get a y value of 3.24. We're going to keep increasing x and start to get closer and closer to the number 2. So look at what happens. As we get to 1.9, we get a y value of 3.61. 1.99, we're getting very close now, 3.96. What about 1.999? We get a y value of 3.996. What about 1.9999? You see we're getting very close to a value of 4, which is actually what is the value when x is 2. But you can see that we are approaching 4 as we get closer and closer to the x value of 2. Okay, this is what we say. The limit of the function x squared as x heads towards the number 2 is equal to the number 4. Now, let's look at it from the other side, as if we were above 2, and we're going to get closer and closer to 2, coming down from the number 3. So 3 squared is 9. 2.5 squared, 6.25, 2.2 squared, 2.1 squared, 2.01, we're getting now close to 2. What about 2.001? And what about 2.0001? Again, from above heading back down, we're getting closer and closer to the value of 4. Right, so this shows us that if we start below the limit of the value of x is 2 and increase, we're getting closer and closer to a limit of 4, getting closer to the number 4. If we start above the value of 2 and work back towards 2, the same thing happens. Now it's important to note, this is a really important idea, a limit exists if the function approaches the same value from both sides of the input value. So our input value here is 2, and as we approach it from below 2, from 1 and get closer to 2, it should be the same limit as if we approach it from above 2 and come back towards 2. Right, now it's best to watch the next video pretty quickly so that you understand what we've just talked about in the next part of it. Cool, thanks for watching.